Hello all, welcome to our new session on high-performance computing. In this session, we will understand high-performance computing in detail, why it is important, where and in which sectors it can be used, how high-performance computing works, a high-level architecture, understand HPC cluster, and go through a few HPC use cases. Let's get started. High-performance computing, commonly known as HPC, is the ability to process data and perform complex calculations at high speeds. To put it into perspective, a laptop or desktop with a 3 GHz processor can perform around 3 billion calculations per second. While that is much faster than any human can achieve, it pales in comparison to HPC solutions that can perform quadrillions of calculations per second. One of the best-known types of HPC solutions is the supercomputer. A supercomputer contains thousands of compute nodes that work together to complete one or more tasks. This is called parallel processing. It's similar to having thousands of PCs networked together, combining compute power to complete tasks faster. HPC is the use of parallel processing for running advanced application programs efficiently, reliably, and quickly. The term applies especially to systems that function above a teraflop, or 1012 floating-point operations per second. The term HPC is occasionally used as a synonym for supercomputing, although technically a supercomputer is a system that performs at or near the currently highest operational rate for computers. Some supercomputers work at more than a petaflop, or 1015 floating-point operations per second. The most common users of HPC systems are scientific researchers, engineers, and academic institutions. Some government agencies, particularly the military, also rely on HPC for complex applications. High-performance systems often use custom-made components in addition to so-called commodity components. As demand for processing power and speed grows, HPC will likely interest businesses of all sizes, particularly for transaction processing and data warehouses. An occasional techno-fiends might use an HPC system to satisfy an exceptional desire for advanced technology. Well, why is HPC important? It is through data that groundbreaking scientific discoveries are made, game-changing innovations are fueled, and quality of life is improved for billions of people around the globe. HPC is the foundation for scientific, industrial, and societal advancements. As technologies like the Internet of Things, artificial intelligence, and 3D imaging evolve, the size and amount of data that organizations have to work with is growing exponentially. For many purposes, such as streaming a live sporting event, tracking a developing storm, testing new products, or analyzing stock trends, the ability to process data in real time is crucial. To keep a step ahead of the competition, organizations need lightning-fast, highly reliable IT infrastructure to process, store, and analyze massive amounts of data. HPC brings together several technologies such as computer architecture, algorithms, programs, and electronics, and system software under a single canopy to solve advanced problems effectively and quickly. A highly efficient HPC system requires a high bandwidth, low latency network to connect multiple nodes and clusters. HPC technology is implemented in multidisciplinary areas including biosciences, geographical data, oil and gas industry modeling, electronic design automation, climate modeling, media and entertainment. Let's understand now how HPC works. HPC solutions have three main components: compute, networks, and storage. To build a high-performance computing architecture, compute servers are networked together into a cluster. Software programs and algorithms are run simultaneously on the servers in the cluster. The cluster is networked to the data storage to capture the output. Together, these components operate seamlessly to complete a diverse set of tasks. To operate at maximum performance, each component must keep pace with the others. For example, the storage component must be able to feed and ingest data to and from the compute servers as quickly as it is processed. Likewise, the networking components must be able to support the high-speed transportation of data between compute servers and the data storage. If one component cannot keep up with the rest, the performance of the entire HPC infrastructure suffers. Let's discuss what is a HPC cluster. An HPC cluster consists of hundreds or thousands of compute servers that are networked together. Each server is called a node. The nodes in each cluster work in parallel with each other, boosting processing speed to deliver high-performance computing. Let's understand some important HPC use cases. Deployed on premises, at the edge, or in the cloud, HPC solutions are used for a variety of purposes across multiple industries. Some examples and use cases are: it is used in research labs. HPC is used to help scientists find sources of renewable energy, understand the evolution of our universe, predict and track storms, and create new materials. Next, in the field of media and entertainment. HPC is used to edit feature films, render mind-blowing special effects, and stream live events around the world. In the field of oil and gas. HPC is used to more accurately identify where to drill for new wells and to help boost production from existing wells. Using artificial intelligence and machine learning. HPC is used to detect credit card fraud, provide self-guided technical support, teach self-driving vehicles, and improve cancer screening techniques. In field of financial services. HPC is used to track real-time stock trends and automate trading. HPC is used to design new products, simulate test scenarios, and make sure that parts are kept in stock so that production lines aren't held up. HPC is also used to help develop cures for diseases like diabetes and cancer and to enable faster, more accurate patient diagnosis. I hope the content was useful. Please subscribe to our channel to stay on top of all upcoming videos. Thank you.